Hi, team. Welcome back. We have looked at. Oh, hold on. We know that vertex form is a really information rich form of the parabola. How do we get a standard form parabola into vertex form? Let's take a look at this example here. And they ask us to complete the square. But I'm going to give you another method to do this because not everyone likes to complete the square. And however you can get this done, you can get this done. So let's take a look. The first method is to know that the x value of the vertex, which is usually we write this hk. So h is always equal to, the x value of the vertex is always equal to negative b over 2a. This is part of your quadratic formula, and it always gives you the x location of the vertex. So in this case, negative b over 2a, this would be, in this case, h would be equal to negative b, so that's negative 9. It's positive 9. 9 over 2. So that's the x value of the vertex. Now I can just evaluate the y value of the vertex like this. Y is equal to 9 over 2 squared minus 9 times 9 over 2 plus 6. And then evaluate that and it will give you k. Okay? I'm not going to do that right now because I do want to, that's just algebra, just plug and chug. This is 81 over 4 minus 81 over 2 plus 6. That's the y value of the vertex, but I'm not going to plug and chug that right now. And then all you would need to do is just substitute the x and y values of the vertex into your vertex form, and you've got it. Let's take a look at how we do complete the square. Okay. The first thing that we want to realize is that we want to create a perfect square trinomial. Our goal is y is equal to a times x minus h squared plus k. And we want to complete this square. We want to create a perfect square trinomial. And the way we do that, I'll just show you the trick, and you can figure out the y later, or ask me about the y. I love to talk about this stuff. Is we take this b value, and we find b over 2 squared. Okay, this is a special number that completes the square. It's the Jerry Maguire number that completes me. So in this case, we have negative 9 over 2 squared. That's equal to 81 over 4. So 81 over 4 is going to complete the square. We add that and then subtract it. So it looks like this. X squared minus 9x plus 81 over 4 minus 81 over 4 plus 6. Okay? Now, this part here is a perfect square trinomial. So let's take a look. This is equal to y is equal to x minus 9 over 2 squared. That is what we wrote down there. Let me prove it to you. X minus 9 over 2 times x minus 9 over 2. This is x minus 9 over 2 squared. So this is going to give us x squared minus, that's x squared, minus 9 over 2x minus another 9 over 2x minus, plus 81 over 4. So now, when I group the like terms, that's equal to x squared minus 9x plus 81 over 4. Because when I take 9 halves and add them to 9 halves, I get 9 wholes. Or in this case, when I take away 9 halves and take away another 9 halves, I've actually taken away 9 wholes. Okay, so that's why that is the same. This here is the same as that. And then I have my k value, it's over here, minus 81 over 4 plus 6. So let's do that. Minus 81 over 4 plus 24 over 4. All I do is I convert that 6 to a fraction, which has a common denominator. 24 over 4 is 6. And then I can add them together. 81 plus 24, negative 81 plus 24 is 57, negative 57. So this is y is equal to x minus 9 over 2 squared minus 57 over 4. Let's input that and see if Delta Math likes this answer. Oops, the bracket went in the wrong spot. Get the bracket in the right spot. Minus 57 over 4. Okay, submit that as an answer. Yes, I like it. Hooray, it's correct. So they do the same thing. They're using decimals in their answers. I use fractions, so it's the same. It's the same process. Mine I can do in my head. If I do this decimals, I'll have trouble doing it in my head. But you want to follow along with these more challenging topics like complete the square. Take a look at their method. Take a look at my method. See what's different. See what's the same. Let's take a look at some where they're a little bit more challenging. And A is not 1. Okay, let's take a look here. Fortunately, 84 is divisible by 7. So this one is actually pretty smooth. Let's take a look at it. So here we go. Y is equal to negative. We want to turn this into vertex form. This, when A is not 1, we have one extra step to do before we complete the square as I showed you, and that's to factor that A out of the A and B terms only. So it looks like this. Y is equal to negative 7 times x squared minus 12x minus 243. Okay, so there I took the 7 out of these two terms, but I left this one alone. He can come down there and just hang out. Okay, now I do the same completion of the square for this bracket. Okay, so I find my Jerry-Maguire number. The b is negative 12, so I divide that by 2 and square it. That's equal to 36. Because 12 is 6 squared, 36. Okay? So I'm going to add and subtract 36 from this. Y is equal to negative 7 times x squared minus 12x plus 36 minus 36 minus 243. Okay? Notice that I put both of the 36s inside the bracket there. Okay? And that's important because I do have to multiply that by this a value out here. So when I bring this 36 out, it gets multiplied by that minus 7. Okay, so let's take a look. Let's keep going. Y is equal to negative 7. This part here is a perfect square trinomial. This is x minus 6 squared. And I actually get that 6 here. It's this number. It's b divided by 2. But I can also verify that by saying x times x is x squared. X times negative 6 is negative 6. Negative 6 times x is the other part of the negative 12. And then negative 6 squared is 36. So it does line up. Now I'll deal with this. Negative 36 times negative 7. It's also useful to have a calculator. 7 times 36 equals, that's 252. I can do that in my head, but then you have to watch me stare at the screen. 200 and, what did I say? 52. Okay. Plus 252. It's positive because there's two negatives. 1, 2. Okay. And then minus 243. That comes down. So this is y is equal to negative 7 x minus 6 squared plus 9. Let's see if Delta Math likes that. Negative 7 x minus 6 squared plus 9. Right. So that is completing the square to go from standard form to vertex form. Any questions, hit me up by email or come find me. Bye for now, everyone.